Exam 1, dynamics for Exam 2, and for Exam 3 we've been focusing on conservation laws. We've brought up the concepts of both energy and momentum, both of which are conserved quantities. Today we're going to start on thermal physics or thermodynamics. This may be similar to something you've heard about from chemistry classes, but we are going to try to motivate all of the things that are happening physically. So we're going to start with a simple example and some definitions. So assume that you have an ice cube in a swimming pool. You know what's going to happen in this case. The ice cube is going to first melt into water, and then that water will eventually reach the same temperature as the swimming pool. The swimming pool is a thermal reservoir. It's a very good example of a thermal reservoir where you know that the temperature will stay constant even when heat is transferred to and from it. This is because the swimming pool is so much larger than the ice cube. So the overall temperature of that swimming pool will not change as the ice cube both melts and then the water that was the ice cube comes to the same temperature as the swimming pool. The ice cube and the swimming pool can exchange heat because they're in thermal contact. So two things need to be in thermal contact in order to exchange heat. And this is one of the things that we need for talking about some of the systems that we're going to talk about today and for the next week. And finally, when the two systems are at the same temperature, they're in thermal equilibrium. And this is one of the concepts that we're going to keep bringing up because we need to be able to change the system and have it come to a thermal equilibrium. When something's in thermal equilibrium, not only are they the same temperature, but no more heat will be exchanged between them. And then all of these cases we've been talking about this idea of heat. We've talked about heat a little bit before when we were talking about potential and kinetic energies. Heat is one of the types, or heat is one of the ways that you can lose energy from a system in those cases. And it is true, heat is a transfer of thermal energy. So when U thermal is changing, increasing or decreasing, then there must be a heat transfer that's been occurring. Heat has the same units of energy, so it has the units of joules, but it actually is only for a transfer of energy. It's not something that you can hold in your hand.